When China's Chang'e 5 mission brought back the first batch of lunar soil, and Tianwen-1 stepped onto Mars, crossing the boundary between heaven and hell, we were leaving footprints one by one upon the ocean of stars. But if we calm down and ask, can humanity really fly beyond the solar system? Or to be specific, can China do it? The answer may leave you in despair. The nearest star to us is Proxima Centauri. Have you ever thought about Proxima? A star so close, a second solar system, yet so impossibly far. What blocks our steps toward that star? It seems right before our eyes, yet in truth the distance is overwhelming. Today, let's uncover the cruel reality behind interstellar travel. From the speed limits of rockets to the survival challenges of the cosmic void, you may walk away with a whole new understanding of just how small we truly are in the universe. Think about this. Earth to the moon is 384,000 kilometers. Apollo 11 reached it in only 3 days. Pretty exciting, right? Now Mars, depending on planetary alignment, can be 225 million kilometers away. NASA's Perseverance rover took 7 months to get there. That sounds long, but on a human scale, it's acceptable. But the moment we bring up Proxima Centauri, the story turns absurd. Do you know how far it is? Over 40 trillion kilometers. Yes, you heard that right. Trillions. At Apollo 11 speed of 39,000 km/h, how long would it take? The answer, 120,000 years. Longer than the entire history of human civilization. That's why scientists don't measure interstellar distance in kilometers, but in light years. Light travels at 300,000 kilometers s, 9.46 trillion kilometers in a year. Proxima Centauri is 4.24 light years away. Even the fastest thing in the universe, light, takes over 4 years to reach it. Now think again. 3 days to the moon, but trillions of kilometers to the stars. This isn't a journey, it's a test of human imagination and endurance. You begin to realize the road to the stars isn't about going slower or faster. It's about being fundamentally impossible with what we have. And this is only the beginning of the story. Remember Voyager 1? Launched over 40 years ago, one of the fastest spacecraft humans have ever built. It travels at 61,000 km/h. Impressive. Yet to reach Proxima, it would take 75,000 years. Even New Horizons, which passed Pluto at 58,000 km/h, would still need 78,000 years. Why so slow? The culprit is our current chemical rocket technology. Since the 1940s, rockets have relied on burning fuel. But the rocket equation is merciless. To go faster, you need more fuel. More fuel means more weight. More weight means even more fuel. A vicious cycle. Simply put, with today's rockets, interstellar travel is pure fantasy. That's why humanity looks to future technologies, light sails, nuclear propulsion, antimatter engines. Maybe they can break these chains, but right now, we're stuck in the slowest gear of the cosmic highway. Now let's talk about energy. Accelerating a spacecraft to just 10% of light speed would consume the equivalent of all the energy humanity uses in a year. And that's only 10%. Push faster, and the energy demand explodes exponentially. Even a 1-gram spacecraft would require astronomical energy to approach light speed. Chemical rockets are hopelessly inefficient. Every time you add more fuel, the spacecraft gets heavier, which in turn requires more thrust, which requires more fuel. The cycle repeats endlessly. So what are our options? Nuclear propulsion, better than chemical rockets, but still far from enough. Antimatter propulsion, the so-called holy grail of energy. Matter and antimatter annihilate, releasing nearly 100% of their energy. A few grams could, in theory, accelerate a spacecraft to near light speed. But the problem? Producing even a tiny fraction of a gram today would cost astronomical sums, and storing it safely is another nightmare. Another idea: light sails. Using powerful ground-based lasers to push giant sails across space. But the required infrastructure is beyond anything we can currently build. In short, the energy demands of interstellar travel are already beyond the limits of our imagination. And then there is time. Einstein's relativity tells us, the faster you move, the slower time flows. Travel to Proxima at 99% of light speed. And for you, only 8 years may pass on the round trip. But on Earth, decades or centuries may have gone by. Your loved ones gone, your world unrecognizable. Even if you could go, would you want to return to a planet where everything familiar has vanished? And what about communication? A message sent to Proxima takes over 4 years to arrive. The reply takes another 4. 8 years for a single exchange. Not a dialogue. A nightmare of silence and delay. Relativity makes interstellar travel fascinating, but also heartbreakingly complex. And survival? Picture yourself inside a sealed spacecraft for decades or centuries. No gravity, no air except what you recycle. No escape. The biggest threat? Cosmic radiation. Earth's magnetic field shields us, but beyond it, we'd be bombarded by high energy. Particles from the sun and distant stars. Enough to shred DNA, cause cancers, damage the brain. Shielding is possible, but thicker walls mean more weight, which means more fuel. The vicious cycle returns. Some scientists suggest using water or even human waste as radiation shielding. It sounds absurd, but maybe it's a way. Then food, water, and oxygen. A spacecraft must be a closed-loop ecosystem. Every drop of water recycled, every breath of air reused, every scrap of waste reclaimed. Even the International Space Station struggles with this. Imagine maintaining it for centuries. Psychology is an even darker threat. Isolation, loneliness. Trapped with only a handful of people in a tiny vessel for decades. Experiments on long-term isolation show mental breakdown is almost inevitable. So maybe interstellar ships must be generational arcs, homes passed from one generation to the next. But are we ready for that? Maybe the greatest obstacle isn't technology, it's the human heart. So can artificial intelligence and robots help? Even if humans can't survive the trip, our curiosity can still fly further. But navigation itself is a nightmare. Imagine aiming a spacecraft at Proxima, 40 trillion kilometers away. Even the slightest miscalculation and it will drift forever into the void. Worse, Proxima isn't standing still. Like all stars, it races around the galaxy at high speed. By the time your probe arrives, Proxima may already be light years away from where you aimed. You must predict its position decades ahead, account for every gravitational tug along the way. One mistake, and your mission is lost forever. At near light speed, you can't correct your course. One wrong angle, and you're doomed to eternal drift. That's why we'll need super intelligent AI navigation, constantly recalculating, dodging dust particles and asteroids, which at relativistic speeds could obliterate a ship on impact. Some scientists even imagine using ground-based lasers to sweep debris from the path in advance. But that too is only theory. In short, without AI, we may never reach the stars, but humanity will not give up. Projects like Breakthrough Starshot are already testing bold ideas. Tiny, postage stamp-sized probes equipped with cameras, sensors, and transmitters, pushed by giant ground-based lasers to 20% of light speed. If successful, they could reach Proxima in just over 20 years. Fusion propulsion, imitating the power of the sun, fusing atoms for immense energy, could shorten journeys to decades instead of millennia. And perhaps one day, antimatter drives will ignite the true age of interstellar exploration. Only then may we finally leave this fragile blue planet and sail into the ocean of stars.